Hey, I want to show you how we calculate the correlation coefficient and how the calculator calculates the correlation coefficient. So we've already put it in the calculator, ran a linear regression. We were looking at, of course, the relationship between the association between the horsepower of cars in 2010 from the sample and the miles per gallon that they got. And we saw it was an indirect relationship. This is a negative linear association between the two. So as we increase the horsepower of the vehicle, of course, power is the rate of consumption of energy. So that means that the miles per gallon is going to go down because it's going to be consuming much more power. So we calculated the correlation coefficient. We found that to be negative 0.9. 9088 or whatever, so that's shown there. We also discussed that the R squared is the coefficient of determination. So the coefficient of determination tells us that roughly 83% of all the variation in miles per gallon can be attributed to or explained by the variation in the horsepower, which is pretty fascinating, and we'll get into that in more detail. So how is the correlation coefficient calculated? Well, the first thing we do is something called standardizing the scatter plot. So we standardize the scatter plot by changing the points that are being graphed in the scatter plot of the and this was an example of height and weight, but we're going to be doing it with horsepower and miles per gallon. We standardize them to turn them into z-scores, which are how many standard deviations they are above or below the mean. So once we standardize it, it looks something like this, centered at the mean point, which is the average miles per gallon and the average horsepower and the average miles per gallon. And then once we get from there, we can go ahead and we can multiply the products of the z-scores and take the sum of the products of the z-scores and then divide those by n-1. And all the ones that are in the first quadrant would be positive, the ones in the third quadrant would be positive as well, and the second and fourth would be negative. So let's go ahead and put that in the calculator, and let's find out how we would do that. So I'll go to stat and then edit, and in list 1, that's going to be the horsepower. List 2 is going to be my list for the miles per gallon. And when I go to list 3, it's actually really fascinating. I learned this trick over the summer. If I go to list 3 and hit enter, actually let me clear this out real quick. Let's see if I can hit clear. Yeah, I'm going to hit clear. So go to list 4 and then hit enter, and I'm going to clear that one out as well. Don't delete it, but I'm going to hit clear because I want to show you how I calculate all those values. All right, so for list 3, I'm going to make this the z-scores for the horsepower. So I'm going to go list 3, I'm going to hit enter. Then I'm going to hit alpha x to put it in as a fraction. And I'm going to put in the formula for a z-score, which is the observation minus the mean divided by the standard deviation. Now, the observation is going to be list 1. So second one, those are going to be the list 1, which is going to be all the data we have here. And then from that, I'm going to subtract that from the mean. Now, I ran 2 variable stats to find out what the mean and standard deviation for each one of these lists are. So I've actually put it in the table that you can see, but the average horsepower was 219.267. Okay, so observation minus mean, and the standard deviation for the horsepower was 72.85648. Okay, and then I'm just going to hit enter. And what it did is it calculated the z-scores, which is lovely, for all of our data. Notice that most of those are going to be less than 2 standard deviations away from the mean, right? Because that's 68% roughly we would expect if it was normally distributed to be within 1 standard deviation. And that's kind of what we're seeing. For list 4, I'm going to define that in a similar way. So alpha x, and I'm going to use our observations from list 2, which is going to be the miles per gallon, minus the average miles per gallon, which I found from running 2 variable stats, so 28.067, and then all divided by the standard deviation for miles per gallon, which is 5.62478. Okay, then hit enter, and those are the z-scores for all the miles per gallon. Now I'm going to graph these out. So I'm going to go to second stat plot, and instead of graphing out the scatter plot for the original data, now I'm going to do the standardized scatter plot, which is going to be the z-scores. So list 3, the z-scores for miles per gallon, and list 4, the z-scores for horsepower. Then whenever I hit zoom 9 and graphs it out, you'll notice if I hit trace, each one of these points here are going to be the z-scores. So I can go through those, and it's going to graph out all my points, which is pretty stinking cool. So you have the z-score for This was 1.24 standard deviations above the mean for horsepower and negative 1.24 standard deviations below the mean for miles per gallon. Of course, it's negative because our association is as a negative association because it's below average miles per gallon and above average horsepower. So anyway, you can see that. You can see the values here that are actually on the mean. So these are going to be the average values for, see if I can find one of those, the average values for horsepower, which is in miles per gallon. Average for miles per gallon, sorry. Okay, so anyway, that's the stat plot, which is actually graphed out here. Now what I want to do is take the product of those z-scores. So I'm going to take each one of these points here and I'm going to multiply them. Let me see if I can show you, which is essentially what we did here. So take the z-score for the x, the z-score for the y, multiply it to get the product of those, then we add them all together. So to do that, we want to, I'm going to quit, no, actually I'm going to go back into stat, edit, and for list 5, I'm going to define list 5 as list 3, which is the z-scores for horsepower, times list 4, which is the z-scores for miles per gallon, and then hit enter. And those are going to be the products of the z-scores. Now I want to take the sum of list 5. So I'm going to quit out to the main, home screen, and I'm going to go to second stat, which is the list option. I'm not going to go to options, but I'm actually going to go to the math operations, and the math operation I want to use is the sum. I'm going to do the sum of list 5. Oh, this is so cool. And that's the sum of the z-scores, which is going to be the sum of the product of the z-scores, which is this part right here. The sum of the products of the list 3 times list 4, that whole thing right there. Then all I have to do is divide that by n-1, which is, if there's 15 in each one, so one less would be 14, and that is going to give me my correlation coefficient, which is exactly what we got whenever we calculated the correlation coefficient right here. Does that number look familiar? Pretty stinking cool. So that's what the calculator is doing for you. It standardizes all those points, creates the standardized stat plot, which we see here, and then takes the product of those z-scores, takes a sum of them, and divides it by n-1. So really, really cool, fascinating stuff. I thought I would share that, but I didn't want to add it to the length of the video because then you would see a 30-minute video and you'd be like, oh, facepalm, not this again. But anyway, so hopefully you guys watch this. If you were interested in the extra stuff, I'll definitely put this in the extension video. So anyway, hope you guys like that, and I'll see you